So far, our time together has been focused on answering the question, how? With Chapter 6, we're going to start working on the tougher question, why? We won't skip around too much in Chapter 6, so let's start on Section 6.1 now. We'll introduce the types of energy and their units. We'll also learn to differentiate between kinetic, potential, thermal, and chemical energies throughout Chapter 6, and how to convert between energy units. Let's begin. Energy is the capacity to do work or to transfer heat. This section focuses on mechanical energy, the energy due to an object's motion, position, or both. Kinetic energy is energy of motion and is described by the formula Ke for kinetic energy equals 1/2 times mass in kilograms times velocity squared, where velocity is reported in meters per second. Potential energy is energy related to position, typically due to gravitational forces. From the diagram, we see that high up on the half pipe, the skater has all potential energy, but no kinetic energy as they are not moving. As the skater moves down the half pipe, the energy of position becomes zero as all the potential energy becomes kinetic energy. As the skater slows on the other side of the half pipe, the kinetic energy is transferred to potential energy. Some energy will be lost from the skater and skateboard as heat due to the friction of the wheels on the surface, so eventually the total mechanical energy will become zero. Energy is measured in units of joules, which are a derived unit because they're made up of the fundamental units, kilograms, meters squared, per second squared. Keep this in mind as you're working through problems and keeping track of the units. An energy unit you're more familiar with here in the US is the capital C calorie or kilocalorie. One little c calorie is equal to exactly 4.184 joules of energy. One capital C calorie is equal to 4.184 kilojoules. Let's work with these units in an example. Suppose a pitcher throws a baseball with a mass of 0.145 kilograms at a velocity of 42.5 meters per second. What is the kinetic energy of the baseball? We already have mass and velocity in the proper units, so let's drop them into the equation. When you do this, you get 131 kilograms meters squared per second squared, which translates to 131 joules of energy. What if we're given the mass and the energy and asked to solve for velocity? Set up the equation, plug in what you know in the correct units, then solve for velocity. A Twinkie snack cake contains 100 capital C calories of energy. Convert this value to joules. As always, I'll leave you with the parting thoughts of the authors.